respected Dean and General Chair of RISE 2023, Professor Abdul Wahid, Head of the Department and Convener of RISE 2023, Professor Pradeep Kumar, faculty, members, participants and dear students, Adab and good morning. I am Mohammad Islam, working as an Assistant Professor in the Department of Computer Science and IT, Maulana Azad National Urdu University, Hyderabad. On behalf of RISE 2023 and Department of Computer Science and IT, Manu, a warm welcome to all the participants on the second day of a two-day 8th International Conference on Research in Intelligent Computing in Engineering, RISE 2023. It is my immense pleasure to introduce our today's session chair, Professor Mohammad Ehsan Chishti Sahab. Dr. Mohammad Ehsan Chishti has done his Doctor of Philosophy from NIT Srinagar. He has completed Bachelor of Engineering and MS in Computer and Information Engineering from International Islamic University, Malaysia, with specialization in computer networking. Before joining Central University of Kashmir as Associate Professor, he was working as Assistant Professor in the Department of Computer Science and Engineering, NIT Srinagar, Hazratbal, Jammu and Kashmir. For more than 12 years, he has more than 70 research publications to his credit and 13 patents with 2 granted international patents. He has successfully completed the Department of Science and Technology, Government of Jammu and Kashmir sponsored research project on IPv6 as Principal Investigator. He has been awarded IEI Young Engineers Award 2015-2016 in the field of computer engineering for the year 2015-16 by the Institutions of Engineers in recognition of outstanding achievement. Contributions made by young engineers in engineering research, excellence in engineering technology development, technology transfer. He was also adjudged with Young Scientist Award 2009-10 from Department of Science and Technology, Government of Jammu and Kashmir for the year 2009-2010. He has received international travel support from the Science and Engineering Research Board, Department of Science and Technology, Government of India in January 2013. For presenting a paper in USA, he is currently supervising a number of research scholars in his research group for the award of PhD degree and has served technical program committees and reviewers of many international conferences and journals. Now I would like to invite Professor Mohammad Ehsan Chishti to chair the technical session number 5 of 8th International Conference on Research in Computing in Engineering RISE 2023. Before that, I will actually tell you, I will name the participant, if it is possible, you please keep your camera on and start your presentation. With the permission of the chair, may I announce the first presenter here?
Please go ahead.
Okay. The first one is Mohammad Nuruddin Rabbani. His title of the paper is Fake News Identification Using Supervised Machine Learning Algorithms. Mr. Nuruddin Rabbani, please proceed.
Yes, sir. Thank you so much, sir. I'm audible, sir?
Yes, please.
Okay, thank you. Good morning, everyone. My name is Nuruddin Rabbani, and my topic is fake news detection using the supervised machine learning. So, in the introduction part, we will talk about the fake news and the fake and real news. What is the fake news? We know we are using many social media accounts like Facebook, Twitter, and some portals like news portals, and we take the information from their websites. So we don't know like whether the information is fake or real. In this situation, we are in this modern era in advanced technology. We have machine learning, so we can identify the news like that is fake or real. So in this case, we just perform some you know perform some classifier on the data we have collected from the Kaggle uh, uh, to identify the fake news and real news. The study says the human brain can detect the 54% of accuracy of the fake or real. That means human brain capacity is only 54%. They can consider or they can assume like the real information or the fake information. During the COVID-19, we know that there's so much news are coming like related to the COVID-19. Some says like COVID-19 is nothing. Some says COVID-19 is spread by the China, and there is some chemical weapon like that. So there's so much news are coming from during the COVID-19 that comes to my mind like whether we have to whether we have to we thought like is it real or not. So that motivated me to do the work on this particular topic. So this is the introduction part. In this graphical representation, I'm just trying to show like the social media and the news on online portals have so much information. So we receive the information on the mobile application. Sometimes we search on laptops. We collect some information from other sources, also like newspaper and etc. So we just apply the machine learning techniques to identify the fake or real news. The problem statements, we already know the problem is for the fake news problem there is some yes.
Your slide is not just press on the slideshow button. Actually, we are just on the first page.
Okay. Just give me a second. Now.
Slideshow karo. You are now in problem statement.
Okay. Let me share one more time. Now, I think.
Okay, now you are in problem statement. Just okay, now fine. Now you can continue.
Yeah, thank you so much. So, the purpose of the fake news is misleading or give the fake information to the public. So this is a major problem. So maybe sometimes political parties do spread the fake news to gain their political benefits. So this is the problem. So in this situation, the literacy or critical thinking also hampered by reading the news, fake news. So in this study, while working with this in this paper, I studied one of the paper related. It was related to the COVID-19 fake news. data set. So they have I found like there is so many COVID-19 misinformation and many the news are coming that day have collected, and the machine learning is applied on that particular data set to identify the fake and real news. In this machine learning model, they have adopted the fake news detection like the RF, like the reinforcement and the gradient boosting and new bias and stochastic gradient boosting algorithm they have used in that paper. So my objectives is to differentiate between the fake and real news, improve the efficiency of the fake news detection, identify the flag and flag the fake news articles, and minimize the impact of the misinformation, enhance the media literacy and critical thinking. Maintaining the democracy. If we talk about the democracy, for the healthy democracy, we should have good information within the public. So maybe misinformation can break the democracy. Support facts checking effect. Steps I follow in this model, like I just collect the data from the Kaggle, that is the secondary data. Someone have already uploaded there. So then we have performed the data processing. Processing is called the cleaning the data. Then I split the data and train the model and evaluate the model. Data processing is essential in performing any machine learning classifier. That contains, like, we have to remove the unwanted unwanted things like null values, extra character, stemming, and the trash. Stemming, we are performing stemming in the NLP because this is a fake news detection. We have perform on the on text based. So we have we use the NLP. So in the NLP we used streaming and vectorization. This is my methodology. In this methodology, I used many supervised machine learning like random forest, passive algorithm, multinomial, new bias, support vector, decision tree, gradient boosting, and XGBoost and logistic regression. The software I used, I performed these machine learning coding on Windows 10 machine and i5 and 16 gigabytes of RAM, 120 GB of SSD. I use a Jupyter notebook and Microsoft Excel for the dataset. Dataset collected from the Kaggle with the name of WellFake. Dataset contains 72,134 news articles, whether 35,028 is real and 37,106 is fake news. Datasets contain the fourth column, like starting from zero, title, and contain text and label.
Mr. Rabani?
Yes, sir.
We have 10 minutes per speaker. You got 2 more minutes to conclude.
Okay. So I'm just finishing my. I'm almost done. Thank you so much.
Thank you, Mr. Rabani, for your speech on the fake news identification in which you have used the supervised machine learning algorithms. Thank you for your talk. Next, we have Ms. J.R. Shruti, who is from Ramaya Institute of Technology, Bangalore. And she will be discussing about deep neural networks for VT supervised semantic segmentation. J.R. Shruti, are you audible? Shruti, can you hear us? No, we cannot hear you. Sure, please try joining again. Will take a moment for her to join us. Alright, by the time she joins, we can start with the next one. And alright, she has joined back.
Hello sir, can you hear me sir?
Yeah, yes, you're audible. Please start.
Okay sir. Yeah sir, I'll share my screen and start sir.
Sure.
टेक्नोलॉजी फेल है तो सब फेल है दूसरी जगह से लोग जॉइन नहीं कर पाएंगे
आ गए
Yeah sir, can you see my screen sir?
Yes, we can see your screen.
Yeah, yes sir.
नहीं है इनमें से कौन नहीं दिख रहा वहाँ पे
Yeah, good morning everyone. My name is J.R. Shruti. Today I am going to present my work, Deep Neural Networks for Weakly Supervised Semantic Segmentation. So in this session, I am going to discuss all these contents, introduction, literature, survey, followed by all these contents, problem statement, objective, methodology, research, conclusion. Coming to the introduction part, semantic segmentation, we can say it's a part of image processing, which can be used to identify entities present in the image, and it's gaining importance in applied research like robotics, self-driving cars, medical imaging, etc. And as I already told, semantic segmentation we are using to identify the entities present in the image. This can be done in the multiple ways by putting the bounding box over the object or classifying each pixel in the image. And much more ways are there. But however, it's not easy always to come up with accurate labels for an image that can be used to train deep neural network. So to address this problem, weakly supervised semantic segmentation technique is proposed, and this technique allows for simplified annotations and makes more accessible in situations where obtaining the accurate label, class labels for the images very difficult. So coming to the literature survey, so we have surveyed some papers. So first paper proposed image attribution and segmentation approach which can identify complex objects present in the image. In this work, they have discussed about the clustering algorithm, that is simple linear iterative clustering algorithm, and they have used MSF algorithm, that is a multi-heat map slice fusion technique, and one more technique that I have used, that is a set to model in order to generate the pixel level annotation. And finally, these annotations are training with the PSP net model and to get the image segmentation result. And the second paper, each category they are labeling with a single annotation, so that this kind of sparse annotation provides prior knowledge about the objects which are present in the image. So this, in order to overcome this issue, this paper aims to achieve pixel level object semantic understanding. And the third one is hypergraph convolutional network for weakly supervised semantic segmentation is proposed. So in this, they have taken graphs, KNN graphs and spatial graphs in order to generate hypergraphs. That is going to be trained with hypergraph convolutional neural network in order to generate pixel level annotations. Through that, they are getting these semantic segmentation maps. And coming to the next one is, so in this new framework, they have come up with a new framework which directly transfers the same classification model in order to perform the semantic segmentation. And the last one concentrated on the graphic algorithm to overcome from the image segmentation issues. Coming to the problem statement, a novel method to generate zero annotations for the images to train multiple deep neural networks in order to product segmentation maps to obtain final segmentation output using weakly supervised semantic segmentation technique. And follow, we have several objects here. We have some objects here. So first what we are doing is we are generating superpixel from the image using SLIC algorithm, and then we are producing accurate class activation maps by using eigencount technique, and generating a zero annotation by combining average activation and saliency maps. And once we get the zero annotation, those we are going to train with the multiple deep neural networks in order to predict the class labels. And then those we are going to translate into the segment maps that is the last objective. So coming to the methodology, so here input image is given to the superpixelization step, and here we are using SLIC algorithm, and then here comes activation map and salience maps are generated. And then we are combining these maps along with the edge detector in order to highlight the edges of the objects present in the image. And then finally we are getting the zero annotations, means like labels we are getting for that image. So we see like how it works. So coming with the first one, linear clustering algorithm for the superpixel generation. So in this we are taking the input image and these are the parameters and number of pixels present in the clusters, and the NYK represents number of pixels in one superpixel. And yes, in the case of length of each superpixel, then how we are calculating this root of NYK. These are the three formulas we are going to use in the superpixel generation. Basically, we are calculating the lab color space distance between the pixels and spatial distance, actual distance between the pixels. So this is here we are using Euclidean distance formula and we are calculating it. Once we calculate it, then we are substituting here in this formula which is final distance. M means compactness factor, which indicates that the compactness of the cluster segments. And S means the step size, which initializes the cluster center. Once we get the result, what it indicates is a smaller distance if you are getting, that means these pixels are more similar and belong to the same class. If you are getting the larger distance, that means they are not similar and they belong to different classes, like that. So this process will be taken place in such a manner to get this cluster segments. And then once it is done, we are going to the next one, super activation map. And here we are generating the activation map. Taking this segment image, we are passing it to the convolutional neural network and it gives activated output. And then eigenvector, first eigenvector will be taken with activated output and getting the activation map. And here we are getting the average activation map for the pixels, and here we are getting the average activation map of super pixels in the image. So this is the output of the second one, and the third one is this one where saliency score of all the pixels in the given image is calculated. So L0 of x indicates saliency score of each pixel located at x, y. Size of xi means number of pixels present in the image. So here we are getting the average saliency score of pixels in the image, and here we are getting average saliency score of all the super pixels in the image. So which generates average super pixel saliency map. This is the output we are going to get. Next we are going to train the deep neural network where we are using two models. Two deep neural network models, that is PSP net model and one more is FCN model. Two models we are using here. Basically what we are doing is we are generating the zero annotation by considering the maximum response value of saliency map and activation maps, and that is going to be compared with the lower threshold value, higher threshold value. If it gives a 0, that means background the label will be assigned. If it is 255 means this will be ignored, and when it comes to this one it will give a specific label category. In order to highlight the objects edges, we are using candy edge detector here. And in this one, once we get the zero annotation, we are going to train the deep neural network, that is PSP net model and the FCN model, in order to get the labels, class labels. Once we get the class labels, that we are going to translate it into the segmentation map. segmentation map in the next step. So all the pixels which are belong to the superpixel will be grouped into one category and they will get a one color. And others will get to mostly likely belong to the other classes will make another group and they will get another color. So this is the output of this combining segmentation map. So coming to the software tools, operating system, we have used Linux, Python 3.7, PyTorch 1.10. Data record, we have used dataset as VOC 2012 dataset. And here 20 different objects. Yeah, yes, sir.
Kindly try to conclude.
Yes. Yes. Oh, sure, sir. And this is the performance metric we have. This is the result we have. So if you see, our method is giving better values compared to the previous studies. In some object classes, if you see, our method values are better than the previous studies. And we have calculated mean IOU. Even though it is less, but for some object classes, we are getting a better value here. And this is the curve we have drawn here. If you see the training loss and validation loss, all are both are decreasing here, also it is decreasing. That means we can see like our model has learned all the features and it's properly fitted for the training. Fitted in the training and it gives proper accurate results. So that is the meaning of these curves. And then the conclusion, what I can conclude is the proposed work yielded better IOU value, that is intersection over union values, for most of the object classes. I'm not telling like all the object classes, but most of the object classes having the better IOU values compared to the previous studies. And as a result, we are getting 48.9 as a mean IOU value. Future studies, what can do is they can combine different multiple neural networks. Here we are combining DSPNet and FCN. They can combine, they can go with the unit segment, deep neural networks to improve the efficiency of all these algorithms. Yes, sir, this is done. These are references. Thank you, sir.
Alright, thank you, Ms. Shruti. It was an interesting talk regarding the implementation of the supervised semantic segmentation. And the next speaker that we have is Phung Thao Vi. She's from International School, Vietnam National University, Hanoi, Vietnam. She'll be speaking about deep learning based image captioning using Keras and TensorFlow.
Sir, can I lead the session, sir?
Yes, madam?
Sir, can I lead the session, sir?
Sure.
Yeah, okay. Thank you so much, sir, for giving an opportunity to present it. Thank you, sir.
Thank you for presenting.
Thank you, sir.
Ms. Phung Thao Vi from International School, Vietnam, National University, Hanoi.
Yeah, I'm here. Wait.
Please start your presentation. You should be presenting on deep learning based image captioning using Keras and TensorFlow. Madam, try to finish it in 10 minutes. Sorry, we cannot hear you. Please unmute yourself.
Oh, sorry.
We can see your presentation. Please start.
Okay, so our study will evaluate the performance of the captioning model using the low magic model for creating caption photos compared with the referring caption. The results show high boost score similar to human subtitle. However, one thing is that those score is meaningless linguistic similarity and n-gram overlap, so it's higher lighting richness. Our finding also the revealed model percentage to convey image essence intake, highlight boost score limitation, TensorFlow and Keras for model development, acknowledging text-wise use but also the limitation. The research offer insight into caption generation model capability and also a broader perspective on caption quality beyond quantitative metric. While high root score are generally preferred, the good score varied with the data sets and context. The study emphasized the need for a more comprehensive approach to assess the quality and creativity of machine-generated captions. Come to introduction. As we know that image captioning bridges the gap between visual contents and descriptive text, also enable application in search, accessibility, assisted, and deep learning has advanced image captioning significantly. So in this research, we'll explore deep learning for image captioning with Keras and TensorFlow, and with a combination of computer vision and natural language processing, it's using CNN for image feature extraction and recurrent neural network with attention mechanism to create coherent and contextual caption, and LSTM for understand image. We'll focus on technique, experiment, and implication. Come to problem statement. Today is the widespread amount of photo information and generated day by day from social media system to surveillance structure, and the heavy computation burden and massive memory storage required by way of present captioning fashion restrict as deployment on a restricted gadget. About literature review, according to image caption and its application, the previous research also applicated image captioning to support blind individuals by way of presenting real eligible caption for photo or adding in medical document generation, or also automating the workflow of the healthcare expert. Regarding to deep learning for image caption, the previous research also used the method of the CNN for image feature and RNN for caption generation. And they also use the evaluation metric like blues or spy or cider. According to moves to objective, the improvement, this research will improve the accuracy of image captioning structure. This can make the contribution to advancement in photographic expertise and human gadget interplay with visual data. The continuing improvement of smart structure capable for information and describing visual content with capability packaged in image search engine, automated content barrier tagging, and accessibility for the visually impaired. But addressing the technical demanding situation and barrier related to deep studying primary-based photo captioning, we offer straight insight into the modern-day country of the artwork and open avenue to destiny study in this rapidly evolving discipline. This is our methodologies described step by step. Data collection, data cleaning, split data into training and testing sets, data reprocessing for image, data reprocessing for caption, model preparation, define model architecture, the training, testing, evaluation, and finally cumulative blue score. We use the model with GG 16 and ResNet 15. For caption model, we use RNN with attention, and for training, we'll compile model and to minimize loss. And for evaluation, we use loop or About software too, we import Keras and expect it, including in this slide, you can see. And this is our data sets for the research. We use the FlickR 8K. It's a Skype portable and wireless view data sets in the field of computer vision and language natural processing is specifically used for tasks related to image captioning. This involves 6,000 chain image, 1,000 depth image, and 1,000 text image. Each picture will consist of description of image content in which every line represents a distinct photograph with a completely unique identifier and multiple descriptions. The description are associated with the content material of the snapshot, often fact about approximately what's happening or what depicted in each photograph. Move to the next part is
Yes. Sir, session
is our result and discussion. So you can see here is our results for evaluate the caption compare with the reference image captioning. It's so high to score limit shade limit. And this is the reference of our research. I think that's all. Thank you for listening.
Thank you so much, Ms. Taoki, for the topic deep learning based image captioning using Keras and TensorFlow. The next speaker that we